Okay, so topographic maps are a way to represent the three-dimensional land surface on a two-dimensional map. And a great way to visualize this is by going into Google Earth. And here we're just west of Fort Collins on the west side of the Horsetooth Reservoir in Laurie State Park. If we look at the Google Earth image, we can see the topography. You know, the hills go up to the west. You know, there's roughly equal elevation running north-south. So take a look at the landscape there and get a sense of what the topography looks like. We can then drape a topographic map over top of this image and see how the topographic lines, the contour lines, correspond to that topography. So here with our topographic map, we can see that these contour lines, the lines of equal elevation, run roughly north-south, and if we go to the west or to the east, we cross over those lines, indicating that we're either going up or down in elevation. Another thing we can notice, if we click back and forth here to turn this on and off, that where the lines are close together, it's steep, and where they're farther apart, it's relatively flat. Final thing to notice is that the contour lines point uphill in the places where there's valleys, where there's little streams coming down. The contour lines form V's that go uphill. On ridges, where there's ridges coming down to the right here, the contour lines form V's that point downhill. And this can help us get a sense of, you know, whether there's a ridge or a valley in a certain area.
For Lab 4, we'll be working on a topographic profile. This will be the main portion of the lab. It's the majority of the work. So we're making this video to demonstrate how to create a topographic profile. So what is a topographic profile? It is a two-dimensional representation of the topography, which is just the changes in elevation along a line. So I have an example here. There are several components. I've got the axes labeled here with their units, and the units are marked off. So we have elevation in feet on the y-axis, and then we have the distance along the profile on the x-axis. That's in miles. So you may notice that this difference in elevation along the y-axis isn't nearly a mile. So we have vertically exaggerated the topographic profile in order to make the changes in elevation clearer. If we were not to vertically exaggerate it, it would just look like a flat line, basically. I also have the directions labeled, so I have west over here and east over there. That's so you know you can orient yourself on the map where the topographic profile is. So I'm going to be demonstrating how to draw a topographic profile using this map. It is a contour map of the Horsetooth Reservoir quadrangle. You can see that up here in the title. The brown lines are contour lines, which you should recognize from your lab manual. And we are going to be making our topographic profile along the line from Arthur's Rock here to the edge of Horsetooth Reservoir. So we're going to be representing the topography along that line. So step one is to take a scrap piece of paper and line it up along the line that you're drawing your profile along, and then mark each time a contour line crosses the edge of your paper. And you can see on the index contours, which are the dark brown contours, I'm making a heavier line. Okay, so now I have all of the contour lines marked. So the second step is to work out the elevation of each of these contour lines. And we do that using, first off, by looking at the legend of the map, which is down here. We can see that it gives us the contour interval here. The contour interval for this map is 40 feet. which means that between each contour line, there's a difference in elevation of 40 feet. However, we can't just start at Horsetooth Reservoir and go up by 40 feet each time we cross a contour line. If you look closely, you can see that some of the contour lines loop around and cross our profile line again. For example, right here, this is an index contour representing the elevation of 5,660 feet. And it loops around here and then comes back and crosses again over here. So that means in between these two lines, and this is the same contour line too, or this contour line loops around and crosses the line of profile twice as well. So in between this little area, we have either a peak or a valley. So how do we tell if it's a peak or a valley? Well, what you can do is peel back your paper and check if your contour lines eventually form a circle. That's a good indication that you've crossed a peak. So in this example, this contour line forms a sort of elongated circle around this little X that says 5,705. That represents a peak. If your contour line is representing a valley, it'll make a V. So here's the 5,600 index contour here. And then it goes off in this other direction here. So that's making a V. And another good tell for when you get a valley is when there's a river marked. So you can see this blue creek line. That's demonstrating that you've crossed a valley as well. So this same 5,600 contour line crosses our line 1, 2, 3, 4, 5 times. So we're going up and down a lot in that area. So I'm going to start with the elevation of Horsetooth Reservoir. They give that right here, the normal pool elevation. The side, if you think of a contour line as a line along which you don't change elevation, and then you imagine how water always seeks its own level, the outside edge of a pool always represents a contour line. And so the USGS has chosen this normal pool elevation, the sort of average edge of Horsetooth Reservoir, and that is a contour line as well. So the normal pool elevation for Horsetooth is 5,430 feet. So that's my first contour line on the eastern side. Then this next one they have labeled right here, that's 5,440 feet. So note that between those two we haven't changed 40 feet. That's because the Horsetooth Reservoir is that special thing. So 5440, and then we go up by 40 feet from there. So the next one's going to be 5480, and then we keep going up 5,520, and then we've reached our first peak. So the next two lines, this one and this one, have the same elevation. So I'll just write those twice. Those are, or once, those are both 540. Then back down on the other side of the peak to 5,520 again. And then we're continuing to go down, so we'll hit 5,480 again. Okay, so you can see you need a really sharp pencil for this, and you have to be pretty careful as you're going through. I recommend keeping the little strip of scratch paper that you are using down on the map until you're done. And in class, because we'll have laminated maps, you can tape it down. So this is what your strip of scratch paper will look like when you finally labeled all of the elevations. I have all of my peaks and valleys figured out, and I know that my final highest elevation over here on the west side is 6,360 feet, which is about the elevation of Arthur's Rock. If you have gone way higher, then something is wrong. And you need to go back and check that you caught all of the peaks and valleys along the way. Okay, so we're done with the map. And the next thing we're going to do is transfer. We're going to essentially make a scatter plot of these elevations using this. So we're going to transfer these elevations to our profile. So now we're going to take our scratch piece of paper that we've been plotting our elevations on, and we're going to use it to plot the elevations along our profile. So we take our scratch piece of paper, lay it along the x-axis of our profile, and then we're just plotting each of these elevations along the y-axis. So you'll need a ruler for this part. I'm just using this piece of paper for my straight edge. And you need to make sure you go directly up from your notch up along the y-axis. Otherwise, you might be stretching out or compressing your profile, and then it's not going to be accurate. So, my first elevation, I have 6360 here. And I've labeled some of the higher numbers, higher elevations along the x-axis. So 6,000, 6,100, this is 6,200, 6,300, and 6,400. So 6,360 is just above the halfway mark between 6,200 or 6,300 and 6,400. So right here. Then we move along to our next notch. Which is at 6,320. And then we have another one at 6,320. And then we just continue to plot each of our points above each of our notches on our profile. So when you finally finish, you'll have all of the dots. I have the dots plotted here. And then you want to draw in just nice natural looking topography to connect the dots. So you need to still have your piece of paper because you need to know where to draw peaks and where to draw valleys. So make sure you haven't thrown that away. And then I marked for myself where the peaks and valleys are, but you can also just go based on the elevations. I have little P's and V's here. And you can see that where there's a little peak there, a little valley there, a little peak there, there's a valley here, a peak here right above that little P. There's a little area there. I didn't go down very far there. I should probably have made that more exaggerated, but it's a less gentle slope there. And then you're just drawing a nice natural looking topography. Don't do straight lines. Imagine what the ground actually looks like and try to draw that. So that'll be part of what you do. And then you just have to finish by labeling everything. So these are not the correct distances, but I have labeled distances here and I put a 0 there. I have my units labeled. The elevations are correct. I have the correct elevations. So this is the elevation above sea level in feet, and then I have the directions labeled. West is this way, and east is this way. And if we compare that to the map, so this is where Horsetooth Reservoir is. And this is where Arthur's Rock is. So what I've drawn here is a representation of how the elevation changes along a line between Arthur's Rock and Horsetooth Reservoir.